Plasma of electrical discharges has multiple applications in almost all kinds of industries, starting from automobile industry to textile industry, where it is used to modify the surface of polymers and textile materials, to semiconductor industry, and even to medicine. What is important is to define what kind of plasma we want to use. And if we define what kind of plasma we want to use, we can then find the application area for that particular plasma. And there we need to have a parameter which can help us to see if plasma is suitable for this kind of application or for another kind of application. And historically, there was multiple attempts to classify plasmas. So to provide some kind of classification for electrical discharges. Among them, there was an attempt to use electron density, ion density, energy of the particles, electrical field. And among all kinds of classification schematics, the most widely used now is the use of velocity of the particles. If you speak about the plasma, all the particles, electrons, heavy particles, ions, they will have a velocity. There will be probability that particles of certain velocity will be found in the discharge. And in thermal equilibrium, the atoms and molecules have if they have Maxwellian velocity distribution function, and this is often the case, then that distribution function can be defined by one parameter. And that parameter we know as a temperature. So if we know the temperature, if we know that particles obey Maxwellian distribution, we can know what the velocity of particles is. And this is a very convenient way to classify the plasmas. The higher the velocity of the particles, the higher the temperature of the particles. The higher the temperature of the particles, the more energy they will have, and at a certain moment, when energy is high enough, they will ionize other particles, and particles' ionization degree will increase, and we will have more and more dense plasma with higher amount of electrons. And indeed, if we put all kinds of plasmas as a function of temperature and function of electron density, we will find there are cases of low ionization degree plasmas, which are typical for the space plasmas. Then there are cases of fully ionized plasmas like solar core. And in the middle of the plot, we will have plasmas of very important technological applications. But even more than that, what is also important is that depending on the number of collisions between the particles, we can have two situations. We can have a situation when collisions frequency is very high, and so particles will interchange the energy between them, and because of this, they will be thermalized. So all the particles will have the same temperature. But we also can have another condition of the plasma where electrons will have very little collisions with heavy particles. Electrons will move fast. Electrons are getting from electrical fields, they are getting energy. And so there will be difference between temperature of electrons and temperature of heavy particles. And we can introduce two parameters. One parameter for very light particles, electrons, and another parameter for heavy particles. For electrons, we will call this electron temperature. For heavy particles, we will call it gas temperature. And with this in mind, we can classify all plasmas in two big groups. And those groups are low temperature plasmas, where temperature of electrons is below 100,000 Kelvin, and high temperature plasmas, where temperature of electrons and ions is above 100,000 Kelvins. Why this number is important? Because this is an amount of energy which is required to break Coulomb barrier between the particles and to start what is called fusion process. And so we have high temperature plasmas. Typical examples are fusion plasmas in tokamaks, in stellarators, and plasma of hydrogen bomb. And there are plasmas of very important industrial applications, and those are low temperature plasmas. In our course, we will focus mostly on low temperature plasmas, and there we will consider two cases. We will consider case of non-thermal plasmas, where electron temperature is much higher than temperature of heavy particles, and we will consider case of thermal plasma, where electron temperature is the same as the temperature of heavy particles. And this we will explain in the next course, which will be nanomodel